Assalamualaikum everyone. As in previous video, we were discussing the refrigeration system. So in today's video, I will discuss the improvements of the refrigeration cycle. The first improvement which we will discuss is the Cascade System. As you can see, there are two refrigeration cycle, and in the center there is a heat exchanger. Now, this cascade cycle is basically used for two environments, and there are also two different refrigerants in this cycle. Suppose the refrigeration cycle, which is below the heat exchanger, is having the refrigerant of R22, and it's supposed to maintain the temperature of let's say minus 10 Celsius. So it will evaporate at minus 5 Celsius in the evaporator, and that same principle of refrigeration goes on. And then in the heat exchanger, when it releases the energy, which is Q out, it could be, you can say, 15 Celsius, and that 15 Celsius will be the evaporative heat energy for the second refrigerant cycle, which is above the heat exchanger, and it could be with the refrigerant of R134A, and it refrigerant might boil at 15 Celsius, and then the same principle goes on, and these two cycle work for two different environments. Now the second improvement is the multi-stage system. It contains two additional components as the flash chamber and the direct contact heat exchanger. Like previously, the cascade cycle was also of a two refrigeration cycle. This is also of two refrigeration cycle. So this multi-stage cycle starts from the evaporator as the refrigerant flow through the evaporator, and then goes into the compressor, then into the direct contact heat exchanger, and again into the compressor of the second stage, and then into the condenser, and from there it enters into the first expansion valve, and then into the flash chamber, and from there into the second expansion valve, and then again into the evaporator. So the flash chamber is actually a separator. It separates the liquid and the gas as the liquid flows down into the expansion valve, and the remaining gas goes right in front of the direct contact heat exchanger, where it direct contacts with the evaporated vapor which are coming from below compressor, and they mix together and goes into the second compressor, and this cycle goes on and on. There's also the TS diagram for this cycle, as you can see. The third and the final improvement is of absorption refrigeration cycle. This is actually a alternative of the compressor, as it consumes the most amount of energy in the refrigeration system. Now, as you can see, there are three additional components, which are absorber, generator, and the pump. The refrigerant which is used in this cycle is ammonia. So, as the ammonia in the evaporator, it evaporates and convert into the vapors, and goes into the absorber, where there is liquid water available, and it is maintained at a very low temperature. So as the saturated vapor of ammonia goes into the absorber, it releases the heat energy and mixes with the water, and it becomes a strong solution, and from there the pump provides take it through to the generator. Now, in the generator, there is a supply of heat so that the ammonia and the water vapors can be separated, as ammonia is reached to its certain pressure, so it goes into the condenser and the remaining water vapor goes back into the absorber through a valve, and its solution is of weak concentration, and this cycle continues from the condenser to the evaporation valve and then back into the evaporator. So these were the improvements of the refrigeration cycle. Now in the next video I will discuss some other engineering process. So do like and comment in this video and subscribe my channel for other engineering videos. So thank you so much. Khuda Hafiz.